Good afternoon students. Today I am going to discuss about coarse dispersions. Under the coarse dispersion subtopic is suspensions. Coming to the aim of the session, to familiarize students with the basic concept of disperser systems, that is coarse dispersions, under that suspensions. Coming to the instructional objectives, this session is designed to demonstrate disperser systems, and second one is describe the classification of disperser systems and list out the various suspensions and describe the characteristics of suspensions. And learning outcomes of the session are, at the end of the session you should be able to describe pharmaceutical suspensions and its role in the pharmaceutical sciences, and discuss the desirable qualities of pharmaceutical suspensions, and discuss the factors that affect the stability of suspensions, and define and calculate the two useful sedimentation parameters, that are sedimentation volume and degree of flocculation. Let us start the today's session, that is disperser system. The term dispersed system refers to the system in which one substance is distributed in discrete units throughout the second substance. Means here if you take any system or any disperser system, the disperser system indicates one substance, one part of the disperser system will be distributed throughout the another part of the medium. That is, means one phase is disperser phase and second phase is dispersion medium. Within the dispersion medium, the disperser phase is distributed uniformly throughout the medium. And here examples for here, each phase can exist in the, if you take the states of matter, the each and every substance will exist in three different states, that is, those are solids, liquids and gaseous state. Here based upon the type physical state of the material where it is distributed, the disperser system will vary. And here the disperser systems, there are mainly two different types of coarse dispersions are there. Those are suspensions, and these are heterogeneous systems consisting of two phases, and emulsions. Emulsions also comes lie under coarse dispersions only. Here if you take suspensions, in the suspensions the disperser phase is a solid and the dispersion medium is a liquid. And if you take if you see the diagram here, in this the solid solute particles are distributed in the liquid medium. As these solute particles are distributed, solid particles are distributed in the liquid medium, because of their particle size and densities, those particles will settle down to the bottom of the container depending upon the particle size. Okay, these are called suspensions. And next, coming to the emulsions, second type of disperser system or coarse dispersions are emulsions. Here emulsions contain disperser phase as liquid. Here solid phase will not be there, only liquid phase or the disperser phase also liquid, and the dispersion medium is liquid. In the case of emulsions, the disperser phase and dispersion medium both are liquid, and those are immiscible liquids. They won't miscible with each other. If you take water and oil and water both are immiscible in nature. Here you can see the distribution of one liquid droplets in another liquid. Here yellow color liquid indicates oil globules, oil droplets. In the blue color liquid indicates water. Here oil droplets are distributed throughout the water medium. In the second one, oil is indicated with oil, yellow color, and blue color indicates water. Here water is distributed in the oil. Here oil in water, oil is the internal phase, that is dispersed phase. So it is given as oil in water type of emulsion, and here water is the in dispersed phase. It is the second one is given as water in oil type of emulsion. Here a solid in the liquid dispersion in which the particles are colloidal size. Here the disperser system they contain two different types of phases. One is disperser medium or dispersion medium. Second phase is disperser phase. Here the dispersion medium, it may be either aqueous or oily liquid. Both the cases may be possible. And in the case of dispersed phase, the insoluble solid material or immiscible liquid material will be there depending upon the type of the coarse dispersion we have taken. If the type of the colloidal coarse dispersion is a suspension, here the dispersed phase will be insoluble solid material. If you have taken as a emulsion as the dispersed system, then the dispersed phase will be oil in nature. Coming to our present topic, that is pharmaceutical suspensions. What is a suspension? A suspension, pharmaceutical suspension, is a coarse dispersion in which internal phase, that may be either therapeutically active ingredient, is dispersed uniformly throughout the external phase. A pharmaceutical suspension is a coarse dispersion in which the internal phase is dispersed uniformly throughout the external phase. Otherwise, you can say that pharmaceutical suspension is a biphasic liquid dosage form in which insoluble solid materials are evenly distributed throughout the liquid medium. Here, internal phase consisting of insoluble solid particles having a particle size range of 0.5 microns to 1 millimeter particle size range. Here the particle size range is 0.59 microns to 1 millimeter size. Means in the previous session we already discussed about colloidal dispersions. In colloidal dispersions, 1 to 0.5 microns, 1 nanometer to 0.5 micron size is the size requirement for colloidal dispersions. 0.5 microns to 1 millimeter. 0.5 microns are nothing but 500 nanometers. 500 nanometers to 1 millimeter particle size range, particles lie under coarse dispersions. Here the particle size is maintained at this particular size range, and which is maintained uniformly throughout the suspended vehicle with the aid of single or combination of the suspending agent. Here the external phase, that is suspending medium, is generally aqueous in some instance, and either it may be organic or oily liquid for non-oral use. If you are going for oral use, generally the liquid medium will be water only. If it is of external use, non-oral use, then the liquid medium may be either oily liquid or organic liquid. Here, what are the reasons for formulation of pharmaceutical suspensions? Generally we are having so many dosage forms, right? What are the main reason? What is the main reason for formulating the suspension? Here, if you want to prepare a solution, you have to dissolve the drug in the water or any solvent material. Especially for oral use, you have to dissolve the drug in the water. But almost 70% of the drugs are insoluble in water. If the drug is insoluble in the vehicle, whatever the vehicle you have taken, in such cases, if you distribute or if you make a suspension with the particular drug material, then it will be given as a pharmaceutical suspension only. If the drug is insoluble in the vehicle, the suspension is a choice of dosage form. Next one is to mask the bitter taste of the drug. Some types of drugs are bitter in nature. If you have dissolved that drug in the liquid, it will give some bitter liquid. So it is not possible to swallow the liquid by the patient. So patient compliance will be reduced. So if you make the suspension with the drug material and if you add any sweetening agents in the preparation, the bitter taste of the drug will be masked, and at the same time the patient compliance will be increased. And third reason for the designing of the pharmaceutical suspension is to increase the drug stability. Here for this, if you take some types of drugs, they are less stable when they are dissolved in the liquid medium. In such cases, if the drug is solubilized, the drug is undergoing degradation reaction. If you have maintained the drug as like in the particle manner only, In such cases, the drug will not be degraded that much fastly. So if you have given the drug in the form of suspension, so by that way what will happen, the drug is not available in the solution form, molecular state, so the drug degradation will be prevented. And fourth reason is to achieve the controlled and sustained release of the drug material. And some examples of pharmaceutical suspensions are antacid oral suspensions, antibacterial oral suspensions, dry powders for oral suspension. Those are generally dry powders, they are nothing but dry syrups. Analgesic oral suspensions, anthelmintic oral suspensions, anticonvulsant oral suspensions, antifungal oral suspensions. And coming to the classification of the suspensions are classified based upon different phenomena. If you are based upon the general classes of the preparations, these suspensions are classified into mainly three types. Those are suspensions meant for oral administration, that is, those are oral suspensions. Examples are paracetamol suspension, antacids and tetracycline hydrochloride suspension. Here these are used for mainly for pediatric administration. And suspensions meant for external application, externally applied suspensions. Example, well known example is calamine lotion. And suspensions meant for parenteral use, those are procaine penicillin G suspension and insulin zinc suspension. And suspensions classified according to the proportion of the solid particles. Depending upon the proportion of the solid material dispersed phase, the suspensions are two types. First one is dilute suspension, in which the concentration of the solid material is 2 to 10% weight by volume. Those are examples are cortisone acetate suspension and prednisolone acetate suspension. And second classification is concentrated suspensions, where the concentration of the solid material in the dispersed phase is 50% weight by volume of the total suspension. Example is zinc oxide suspension. And next one is third classification. The suspensions are classified based upon the electrokinetic nature of the solid particles, means electrical properties of the solid particles. They are classified into two types. Those are flocculated suspensions and deflocculated suspensions. Next, another classification is based upon the particle size of the solid particles. Here, if the suspension particle size is less than 1 micron or less than 0.5 microns, those are given as colloidal suspensions. Here, the colloidal suspensions, what is the particle size? 1 nanometer to 500 microns. If the particle size range between 1 nanometer to 500 nanometer size range is giving, those suspensions are given as colloidal suspensions. And next, coarse suspensions. Here the particle size range will be more than 1 micron, greater than 1 micron. Almost all the marketed suspensions what we are having, all are coarse suspensions only. And the third one is 1 nano suspensions. Suspensions are biphasic colloidal dispersions here less than 1 nanometer it is. Coming to the advantages of suspension. Here in suspensions, they can improve the chemical stability of the certain types of drugs. Here procaine penicillin G is the example. If you dissolve the procaine penicillin G in the liquid medium, because of solubility of the procaine penicillin G, the dissolved part is undergoing degradation very fastly. So if this procaine penicillin G is made as a suspension, the stability of the procaine penicillin G has been increased. So that is the advantage what we have achieved. And next one is, if you compare the bioavailability of the dosage forms, after solutions, suspension is the most highest bioavailability containing preparation. Duration of onset of action can be controlled. We can control the duration of action and onset of action of the drug material. And suspension can mask the unpleasant and bitter taste of the drug molecule. Example is chloramphenicol. Coming to the disadvantages. Physical stability is the main problem with the suspensions. Why? Because here the drug molecules are suspended through in the liquid medium. As these are not solubilized and they are having large particles, some little bit particle size is more, and the density difference in the liquid medium and the dispersed particles, the particles will undergo sedimentation after when we stand up for storage. The sedimentation of the particles will lead to sometimes hard cake formation, which is not possible to redisperse. So in such cases, that may be the problem with this suspension. Sedimentation is the problem. If the sedimentation prolonged for longer periods of time, this may leads to caking of the suspension. It is bulky, sufficient care must be taken during handling and transport. Here in case of suspensions, we have to provide proper handling and transport conditions. If not provided, during the handling and transport, the container may be broken and the total contents will be wasted, and it is difficult to formulate. Yes, we need to consider so many parameters to formulate the suspension. Why? Because we are not using simple solute and solvent, right? The solute particles are distributed, those are not dissolving. So whenever the particles are not dissolving and they are distributing in the liquid medium, we need to consider their particle size, the density difference, and viscosity of the medium also. So all these parameters need to be controlled and need to be taken into consideration to formulate the suspension. So much skill is required to prepare the suspensions, and uniform and accurate dose cannot be achieved unless suspensions are packed in the unit dosage form. Here suspensions, if the particle size is not uniform, in such cases uniform doses will not be possible and accurate dose are also possible. Why? Because the particles are completely distributed in the medium. If you shake the container before use also, the particles, if the particles are uniform in size, it may be possible. Okay. So if it is not uniformly distributed, in such cases it will be the problem with this suspensions. Applications. Here suspensions are usually applicable for drug with insoluble, just whatever the reasons what we considered for designing of the suspensions, all those reasons will be come under application part. For an ideal suspension, we need to consider these points. What are they? It should be it should not settle rapidly and it should be easily resuspended with the moderate amount of shaking. It should be easy to pour, not watery or not grittiness, and it should have pleasant odor and color. Palatability should be there. It should have good syringeability. It should be physically, chemically and microbiologically stable, and parenteral ophthalmic soil suspension should be sterilizable.